A 5 cm diameter steel pipe is covered with 1 cm layer of insulating material having thermal conductivity 0.22 watt per meter centigrade, followed by a 3 cm thick layer of another insulating materials having K 0.06 watt per meter centigrade. The entire assembly is exposed to a convection surrounding conditions of H equal to 60 watt per meter square centigrade, and the outside environmental temperature is 15 centigrade, and the outside surface temperature of the steel pipe is 400 centigrade. Calculate the heat lost by the pipe insulation assembly for a pipe length of 20 meter expressed in watts. So we need to find the heat transfer, heat loss from this pipe up to the length of, what is the length, that is 20 meter. Okay, so the internal dia of the pipe is 5 centimeter. 5 centimeter, convert into meter, just divide with 100, so 0.5 meter. So inner radius of the pipe is di divided by 2, so that is 0.05 divided by 2, so you will get 0.025 meter. The pipe is covered with 1 centimeter layer of insulating material. The steel pipe is then covered with this insulating material. Its thickness is x1. First insulation that is provided is 1 centimeter, means 0.01 meter, and its thermal conductivity K1 is 0.22 watt per meter centigrade. And then the second insulation that is provided, its thickness x2 is 3 centimeter. So 3 centimeter means 0.03 meter, and its thermal conductivity x2 is 0.06 watt per meter centigrade. The entire assembly is exposed to the environmental conditions H, so the outside convection heat transfer coefficient is 60 watt per meter square centigrade. And the outside temperatures is to infinity 15 centigrade, and the temperatures, surface temperatures, outside surface temperature of the pipe is Ti, that is 400 centigrade. Need to find the heat transfer, that is our requirement. Heat loss that is occurred through this pipe by providing 2 layers of insulations up to the length of 20 meters. So here I draw a simple sketch of this problem statement. So this is the pipe. Its inner radius is Ri. So a first layer of insulation over this pipe is provided, that is x1. Its thickness is x1, let's say. And then second layer of, this is the second layer of insulation that is provided on this pipe. Its thickness is x2. From the center to this point, the first layer of insulations, its radius is r1, and then from this center to the external surface of the second layer of insulations, the radius is r2. So this ri is equal to 0.025 meter. this R1 is equal to Ri. If you look at this diagram, it's equal to Ri plus this thickness of the first insulation plus x1 x1, sorry, that is equal to 0.025 plus 0.01, so it become 0.035 meter. Now the R2 will be equal to R1 plus x2. So if you look at this diagram, if I am trusting to find the R2, so it will be equal to R1 and this extra portions of the insulation that is provided, that is x2. So it will be equal to R2 is equal to R1 plus x2. So what is R1? It is 0.035 plus x2, it is 0.03. So after adding, you will get its value, that is 0.065 meter. Now the surface temperature of the steel pipe is Ti. The outside temperatures here is T infinity. If I draw the resistance network diagram, so from the surface of this pipe, the heat transfer through this first insulation is occur. So it is obvious it will offer the resistance to the heat transfer. So first layer resistance to the heat transfer, then second layer resistance to the heat transfer, and then convection heat transfer resistance, it is outside, and then finally T outside, and this is the surface temperature of the pipe. So this is R1 resistance offered by the layer 1 of the insulations, layer 2 resistance insulations, and this is R3, and this is convection resistance that is outside this pipe. Okay, so the R1 value is equal to ln R1 divided by Ri divided by 2 pi K L. So what is ln? What is Ri? Ln is a natural log, so R1 is 0.0 divided by Ri, 0.025 divided by K value of the first insulation 0.22 multiply by length, that is 20. So you will get the value, that is after simplifications on calculator, 0.01216. R2 value is equal to ln R2 divided by R1 divided by 2 pi K to L. So ln, here it is K1, R2 that is 0.065 divided by 0.035 divided by 2 pi multiplied by K2, that is 0.06 multiplied by 20. So you will get answer after simplification, that is 0.0821. Next is the R3, that is equal to 1 divided by HA. So 1 divided by H multiplied by A is equal to 2 pi R2 L. This is the surface area of this pipe. R2 is the radius from the center of the pipe till its outermost layer of insulation. 1 divided by H. H is 2 pi. R2 is 0.065. Length 20. So you will get the last resistance that is offered to the heat transfer is 2 multiplied by 10 to the power minus 3. So just add these three resistance to get the total resistance, that is sum of R1 plus R2 plus R3. So it is R1 0.01216, 0.0821 plus 2 multiplied 10 to the power minus 3. After adding, you will get the resistance that is offered to the heat transfer. So that is so you will find 0.09626, 0.09626. After that, so the heat transfer is equal to the temperature difference divided by total resistance that is offered to the heat transfer. So what is temperature difference? That is 400 minus 15 divided by 0.09626. So when you simplify this value in calculator, you will get the heat transfer. So let me solve it. 400 minus 15 divided by answer equal, so you will get 3999 watt heat transfers through this pipe will occur till its length 20 meters if 2 layer of installations is added. And these are final answers. I hope you understand. If you still have any confusion, you can ask.